Okay, so let's start. Okay, good afternoon, class. Okay, first things first, as much as possible, I'm gonna be honest, no? As much as possible, gusto ko magbigay ng mataas na grade sa inyo. Okay? So, goal ko makapagbigay ng line of 1 lahat na grade sa inyong lahat. Pero, I can't do that without pag hindi nyo ginawa yung part nyo. Siyempre, I can't magically give you high grades, di ba? So, you have to help me. Okay ba yun? Okay ba yun? Kasi ang hirap eh. Hindi ko alam kung saan ko huhugutin yung grade ko. Hindi naman ako pwede magbigay ng mataas, pero bara-bara lang yung gawa nyo, di ba? Mahirap naman yun on my part. Okay? So, I feel good when I give high grades. Pero kailangan merit yun, by merit. Okay. So, bakit ko ba sinasabi yun? Okay, so over the reading break, nag-check ako ng mga works nyo. Hindi ko pa in-upload yung grade, no? Okay. Kasi yung sa exam, di pa tapos ni Sir Baguno yung solutions. Or at least di niya pa nabibigay sa akin. Okay. So, hindi ko pa na-checkan totally yung mga grades niyon. Pero may grade na siya sa, sa Excel files ko. Okay. So, ayun, nag-check ako and nakita ko, medyo na-disappoint ako dun sa mga gawa niyo sa problem set number 4. Well, another problem sets din naman. Sige, I shall raise my concern. Share screen ako. Thumbs up kung kita na. Okay, sige. So, binalik ko lang tong lesson natin. Okay, so problem set 3.12. Two long straight copper wires, copper pipes, each of radius r, are held at a distance 2d apart. Okay. So, ito yung problem set nyo, no? One is at a potential V0, and then the other as in negative V0. Okay? Now, find the potential everywhere. Tapos, sinabi niya na pwede nyo i-exploit yung result ng problem 2.52. Okay? Okay. It's good. Okay, so what is the goal here? Tandaan nyo lagi yung goal sa problem set nyo. Okay. Find the potential everywhere. Okay, so that's the goal. So, lagay nyo muna sa likod ng utak nyo yan. Okay. Now, let's look at the solutions. Okay. So, kita na ba? Thumbs up kung kita na. Okay, so zoom out lang natin ng onti. Yeah. Okay, so ito yung solution set nung problem set number 4. Okay. Sa mga solution nyo, okay. Okay guys, alam ko na nakikita nyo yung solutions ni Griffiths. Okay, kasi lahat kayo pare-parehas ng sagot. Okay. Lahat kayo pare-parehas ng sagot. Alam ko nakikita nyo yung solutions dito somewhere in the internet. May solutions na lahat ng problems ni Griffiths. Okay? So, mga solutions na yan. Ngayon, alam kong ginagamit nyo yun. And that's okay for me. Okay? Kasi learning pa rin yan. Okay. What I'm, bothered lang ako na yung marami sa inyo na kumopya lang nung sagot niya without much explanation. Okay? Okay, so ang punto ko para bigyan kayo ng, di ba sabi ko sa inyo, yung mga problem set nyo, kailangan may explanation na full sentences, ganyan. Okay? So, ang point lang nito is hindi kayo bigyan ng extra work, no? Hindi naman ganun. Ang point ko is para ma-explain nyo yung mga steps in between na hindi sinusulat ni Griffith sa mga solutions niya. Okay? Okay, so okay lang, gumamit kayo ng solution, pero lalagay nyo siya ng bridging statements. Ayun yung gusto kong makita. Okay, hindi lang basta nagsulat kayo ng mga phrases that would pampahaba lang ng ginawa niyo. Okay. Hindi maganda 'yon, okay. Kailangan mo explanation niyo, i-bridge niyo yung steps. Okay. Okay. So, paano ba magsagot ng prompt set? Sige. Okay. So, i-focus niyo lahat yung unang paragraph niyo para sa point of attack niyo. Okay? So, paano nyo ba isosolve yung problem? Okay, so basahin natin. To solve for the potential everywhere, we can use the idea of method of images by placing line charges inside the pipes. Okay? So, kasi di ba nakita natin sa circular na thing, naglagay tayo ng point charge. Okay? Sa spherical natin. So, paano pag in-extend natin to sa pipe? Pwede na tayo mag-isip na ngayon pwede tayo maglagay gumawa tayo ng method of images by placing image line charges. Okay? So, imaginary line charges lang to inside the pipe. Okay? Sabi ni Griffiths, pwede nyo exploit yung result ni 2.52. So, we can exploit the result of 2.52 for this. Okay, bakit? Bakit ba natin pwede yung gamitin yung solutions ng problem 2.52? Kasi, dito sa problem na to, the potential of two oppositely charged, tinakil dun yung potential ng two oppositely charged line charges. Okay? So, kasi ang gusto natin, mag-method of images tayo. Paano? By placing line charges. Tapos, yung result ng 2.52 is yung potential na agad ng mga line charges. Okay? Okay. So, in problem 2.52, the potential is given by, okay, V is equal to this. Okay. So, hindi ko siya sinolve kasi pwede ko raw exploit eh. But I have to explain where this is coming from. Okay. So, this is for line charges with lambda na density, the positive running parallel with z-axis, at x equals a, y is equal to 0. So, sa xy plane siya. Tapos, nakatutok siya sa z hat. Tapos, nakapwesto siya sa x equal to a. Okay. And the negative sa other side, which is in the negative a. Okay? Okay. Then, y is equal to 0, of course. Nasa xy plane niya, di ba? Okay. Okay, so if this is the potential of the image charges. So, ito yung potential nung nilagay mong imaginary charges sa loob ng pipes. Okay, then we must ensure that the potential at the surface of the pipe is plus or minus V naught. Okay? So, paano ba natin magagawa yun? We can let this guy. Okay, bakit? Medyo may kulang akong step dito. Nagkamali na ako, tas it was too far to change things. Okay, pero I hope na-gets nyo naman kung bakit. Kasi, we can let this guy, itong x plus a something, basically yung loob ng ln, gagawin ko siyang exponential. Kasi, di ba magka-cancel yung ln tsaka yung exponential? Ayun yung purpose nun, di ba? Para ma-ensure mo na v naught yung potential mo. So, lalagay ako ng something inside the ln that would cancel out. So, that is your exponential function. And makikita nyo, magka-cancel ln, cancel lambda, 4 pi epsilon naught, matitira si v naught. That's your goal, di ba? Okay. So, we have this. Then, tinry natin i-simplify. Okay, for brevity lang to para dumali buhay natin kasi nakakapagod magsulat nitong whole thing. So, sinulat natin siya as K, which simplifies here. Okay? Actually. Okay. So, inayos lang natin to equation number 2 para mag-equation number 3. Very simple. Okay, may kulang na naman akong step. So, that's on me na. So, we can explore the equation of a circle centered at D, 0, with radius R. So, bakit natin ina-explore yung equation ng circle? Kasi, again, ina-exploit natin yung results ng problem 2.52. Kasi sinabi ni Griffiths that yung potential ng line charges would have equipotentials na circular. And yung pipes natin, circular din. So if we want the surface of our pipes to be equipotential, gusto rin natin yung equipotential na pinoproduce ng line charges would be equipotential. Diba? So tingnan natin. So dapat mapapattern natin yung circular pipes natin sa circular equipotentials ng imaginary line charge natin. Okay. So we can explore the equation of a circle centered at D0. So in D0 at with radius R, ito yung specs nung pipe. Ito yung specs nung natin, yung pipes natin, di ba? Kasi sinabi sa problem na centered at D tapos radius R. So tinignan natin ngayon kung paano yung equation of circle with that guy. Okay, so we have equation 4. Now equation 4 and equation 3, compare natin. Makikita natin that A squared is D squared minus R squared, this term. Kasi may X squared na tayo, may Y squared na tayo, then may 2dx. So, pag tinignan natin sa kabila yun, may x na dito. So, this guy is occupied. And then, x squared plus y squared. Occupied na rin yan. Yung constants na lang yung natitira sa atin, which is a squared. And in this part, b squared minus r squared. Okay. That's it. Okay. That's equation 5. Okay. Now, what does A tells us? Okay. Si A, doon nilalagay yung mga line charge mo, di ba? Ayun yung ano natin, yung ini-exploit natin. So sa problem 2.52, sa A mo raw nilalagay si line charge with lambda density. Okay, now that we have solved A, now that we know where to place the line charges. Di ba? Kasi sa method of images mo, ang goal mo is malaman mo kung saan nilalagay yung line charge and then malaman mo kung gaano sila kalakas. Okay? So next, we need to know how strong those line charges are. So actually, we are done. Tapos na tayo, no? We can set the potential to V naught plus or minus V naught in this equation, number 1. Plug in mo dito sa V naught. And then, the x and y values according to equation 4. So, kailangan masatisfy mo lang si equation 4 and then si equation 1 with V naught on the left-hand side. Okay? Okay? So, tapos na. We just want a simpler form or mas magandang form, di ba? Okay. Okay. So, para magawa yun, we can simplify the form by solving for x in equation 3. Tingnan natin kung ano yung mga values na pwede kay equation 3 in here. Okay? So, syempre, ano lang to, quadratic equation, ayusin mo lang. Makukuha mo na yung solution for x will be some constant, this guy, plus or minus this. Okay. So, yung k, define natin kanina. Okay. We see that this is similar to x plus d plus minus r. Okay? So, kung ipapattern mo yan, makikita mo na si r ay equal si d muna, si d ay equal to the first term, and then r would be equal to the second term. Okay? Okay, with these guys, so dr and d and r, makakakuha ka ng equation that gives you lambda that is not dependent on a. Okay? So we want to eliminate a kasi gumagawa tayo ng technique lang, di ba? Yung method of images, parang hocus-pocus kasi pag ginamit pa yung a dun sa imaginary solutions mo. Okay, so we don't want a. We have to use the specs given to us. So, nakita ko to na ginawa nyo lahat to pero walang naka-explain kung bakit ba natin ginagamit to. Okay? So basically, parang pampaayos lang siya ng form. Okay? So, we divide d by r. Makuha natin that is yung cotangent, hyperbolic cotangent, tsaka yung hyperbolic cosecant, yung quotient nila, yung division nila, would just be equal to cosh. Okay. Hyperbolic cosine. And then, makuha mo na si lambda, which is this guy. Okay. Now, we have solved how strong and where to place the line charges. We are almost done. Okay, bakit almost done? Kasi ang tinatanong, the potential everywhere. Okay. So what we have solved is outside the pipe, which is given by equation 1. Equation 1 mo ay yung in-exploit natin. This guy. And then, equations 5 and 10. So, si 10 ay yung sa lambda, si 5 ay yung sa A. Okay. So again, A tells you where to put the imaginary line charges. And 10 lets you know how strong those line charges are. Okay? So, inside the pipe, the potential, okay, wala nakakuha na to. Inside the pipe, the potential is V naught because of the uniqueness theorem. Okay, so sa uniqueness theorem, nasabi sa atin na yung potential on the boundaries must be the minimum or the maximum already. Okay, so kung Kung constant yung potential all over that surface, therefore, inside of that surface, ganun lang din yung makukuha mo. Kasi, ayun na dapat yung minimum at maximum. Okay? So, inside the pipes, that would be plus or minus V naught. Okay? And outside the pipe, ito yung makukuha natin. So, si A and lambda are defined again with 5 and 10. Okay. So, ang ayos, di ba? Pag in-explain mo siya na systematic. Okay. So, ayun lang ang punto ko, guys. Ayun lang yung gusto kong mangyari sa pag-aano natin. So, ipopost ko naman to. Pinopost ko naman lagi yung pinopost ko lang naman lagi yung solutions. Okay? Minsan nga lang matagal. Dahil ako ay busy din. Okay. So, ayun no. So, as much as possible, try to explain things systematically. And, kung hindi nyo talaga mag-gets, guys, kung hindi nyo talaga mag-gets, mag-consult kayo. Okay? So, dalawa lang nakakuha ng highest score. Pero, yung usual na nabigay ko sa prob set na yun ay 10, ganyan. Yung iba may naka-15 naman. Pero yung highest would be 19 and 18. Nandito silang dalawa. Si Ross, 19 yan. Doon sa prob set na yun. Okay, kasi well explained sa kanya. In-explain niya. Pero hindi niya nakuha yung yung potential inside the pipe. Parang nakalimutan niya yata yung tinatanong ay potential everywhere. Okay lang yun. Very good pa rin. Very good, very good. Galing. Okay, and then yung 18, si Danny. Amazing. Si Danny, nag-consult siya. Okay, so nag-consult siya sa akin kung paano ba gagawin itong project na to. So, tinulungan ko siya. I mean, hindi ko siya tinulungan magsagot, pero you have to consult when you don't understand things. Okay? So, ganun, no? Consult kayo pag hindi ko talaga mag-gets yung solution ni Griffiths. May prob set, sir. May prob set. What do you mean? Sorry, may nagtatanong sa chat sa akin. May prob set, sir. What do you mean na may prob set, sir? May prob set ako na ibibigay today? O may prob set akong dinidiscuss ngayon? Kung may prob set ako na ibibigay today, yes. May bibigay ako sa inyo. Pero wala slides, so nagko-curate pa ako ng mga prob sets na maganda ibigay. Okay? Tapos kung yung kanina ginagawa namin, nagdi-discuss kami ng prob set 4. Okay. Okay. So, sa mga problem set, pag may mga straightforward naman na mga bagay, pwede nyo nang huwag pahirapan sarili mo. Kumari, using Gauss's law for a charge sphere. Okay. Straightforward na yun. Alam na natin yun. Kasi di ba, kung nag-Gauss's law ka with that, makukuha mo lang is the total charge Q divided by 4 pi epsilon naught over R squared. You just have to define R, di ba? Just have to define R. Okay? Okay. So, ayan. I hope maayos natin yung mga prob set natin. Okay. So, kasi gusto kong bigyan kayo ng mataas na grade. Again. Okay. Bakit? Bakit ko ba gusto kayong bigyan ng mataas na grade? Kasi, I don't believe that these grades represent yung future mo. Okay? So, baka ngayon iba yung motivation nyo in physics or in life. Tapos, after 4 years, may tumingin ng transcript nyo. Ay, ang baba mo naman sa ganitong grade. Pero iba na yung motivation mo at that time. Malay mo, mas masipag na kayo. Mas may alam na kayo by that time. Di ba parang unfair? Saka sir, pambawi. Very good, yes. Pagpuhunan kayo. Kung medyo nahirapan kayo sa 140. Okay, so ayun, no? Tulungan niyo ako bigyan kayo ng mataas na grade, ha? Guys, okay ba yan? Okay ba yan? Okay. So kung wari, may mga, I believe at this time, may mga third year kayo, di ba? Tama ba? Third year ba kayo? Okay, third year kayo. I believe by this time, some of you have found out that love of your life niyo yung physics. And some of you hate niyo yung physics, pero stuck na kayo. Okay. Some of you, ganun, okay. So, ang goal ay, kung bakit ko to ginagawa is helpful pa rin to in your life, whether you become physicist or not. Okay. To think systematically, to think sequentially, and then to articulate that. Feel ko helpful naman yun. So, kaya ako kayo pinapag-prob set ng, ano, ng, ng medyo maarte. Okay? Okay, sa exam ba required na mag-ganun? Siyempre, parang minsan kasi nagpapanik na kayo, no? Nagpapanik na kayo na sa pagsasagot niyo. So sa exam, sige, wag na natin i-require na lalagyan nyo ng mga step by step mga things. Okay, kailan scheduled exam, sir? Baka next week pa yung exam, no? Okay. Natapos na natin chapter 5 this week. Okay? So, balik tayo sa pag-solve ng exam. So, okay lang, sige, okay lang na medyo kumari ayaw nyo na mag-arte dun sa hindi nyo siya bigyan ng mga paragraph explaining your solutions. Okay lang, okay lang. Pero, what would be the advantage? What would be the advantage na explaining things? Mas pag na-appreciate ko yung sagot nyo, kahit hindi nyo na-solve, kahit kailangan nyo pala i-solve. Pero, it helps me understand your solutions. Kung may mga paragraph na, na extras. Okay? Okay. If nakita ko yung solution nyo, yung na-articulate nyo by words yung gagawin, I give extra points. Kasi gets nyo naman yung problem. Eh. Baka mamaya nahirapan lang kayo sa math. Naalala ko in my master's, meron problem set na binigay. Basically, you have to solve a quartic equation. So, x to the fourth. Okay. So, x to the fourth. Kasi quadratic equation is x squared, di ba? And madali lang ma-solve yun. Madali lang ma-solve yung quadratic equation. Kasi may quadratic equation na, di ba? Okay. Sa cubic equation, may solution na din. Pero sa quartic equation, walang solution. Alala ko lang, exam siya, tapos nagpapasolve ng quartic equation. Sinabi ko na lang, paragraph na lang yung sinagot ko na after the solution has been obtained for this quartic equation. Ganun. In-explain ko na lang siya by paragraph. Na he would use the roots for this quartic equation to solve for this. Kasi I'm not a computer. Hindi ko kaya mag-solve ng ganun. Or baka banu lang ako mag-solve ng math. Pero ang taas nung nakuha kong score. Kasi alam ko naman yung gagawin ko. I just don't have the mechanism to answer the roots of a quartic equation. I don't know that. Okay, so, ayan, again, sa mga hindi naka-attend lang kanina, so, help me give you high grades, okay? Okay. And of course, consult. Yes, consult kayo pag di talaga mag-gets. Okay, so let's proceed to our lesson. Okay lang mag-consult, guys, no? This is my 4th run. Pang-apat na takbo ko na to sa 130. Okay. Kung di nyo magets on your first run, that's okay. That's very okay. Ako nga, pang-apat ko na to. Tapos, I have to recall things pa rin. Okay, so una is undergrad. Tapos nag-masters ako. Inulit ko yung 130. Tinanong ako ng admissions committee kung gusto ko raw ba ulitin. Sabi ko yes. Tapos, ayun, wala lang, learning. Learning for learning's sake. Tapos yung masters na level ng 131 at 132 o 130 in your case. Okay. Tapos ngayon, pang-apat na siya. Okay. Wait lang, inayos ko lang yung i-share screen ko. Okay. So, ayan, kita na ba? Thumbs up kung kita na. Okay, thank you. Okay. So, sa mga nakapag-recharge na, no? And sa mga gusto mag-on cam, it will be highly appreciated para may kausap ako. Kung wala naman, okay lang din naman. Walang problema. Okay, let's start chapter 5. So last time natapos na natin chapter 4. Okay. Chapter 4, yung chapter 4, ang ganap doon will be electric fields in matter. So last time diniscuss natin electric fields in matter. So paano pag yung matter mo ngayon ay hindi na conductor at hindi na pure charges of electrons and protons? Paano kung molecules na sila na may combination ng positive at negative charges? So that's what we discussed last time. And as far as electrostatics goes, okay, hindi ko alam kung ano yung tamang grammar. We're done with electric fields, okay? Where at least we're done with electrostatic fields. Okay. Ibig sabihin ng electrostatics, static yung mga charges mo nung hindi nag-accelerate. Okay? So now, uulit tayo ng mga bagay-bagay. Okay? Ulit tayo. Basically, this time, we're interested in magnetic fields. Okay? So again, uulit lang tayo. Same process lang sa mga bagay-bagay. What we have to start, of course, saan ba natin hinuhugot tong magnetostatics? Okay. So suppose meron kang baterya. Ayun, may battery ka. Now, i-connect mo yung, syempre positive to negative, di ba? Connect mo yung positive to negative. Then, you have your wires which are electrically neutral. And what do we mean by electrically neutral? E is equal to 0. And when E is equal to 0, ano yung forces na mangyayari sa charges mo? Joshua, ano mangyayari sa charges mo kapag electric field ay 0? Gagalaw ba o hindi? Are you there, Joshua?
Hindi po.
Hindi gagalaw, di ba? Hindi gagalaw. Okay, however, let's look at this. Kapag meron kang wire hanging from hanging from the ceiling siya. Ayan. So, yung dashed line, ayan yung initial state niya. So, from the ceiling, may nakahang ka na straight wires. Tapos, opposite yung currents nila. One going up, the other going down. By experiment, nagulat sila Ampere, no? Nagulat sila Ampere. Bakit? Nagre-repel tong dalawang wires mo kapag kinabitan mo na siya ng baterya. Okay, so nagtataka sila bakit? Kasi you're sure that there is no electric field between them. Kasi nga electrically neutral sila, nakasurround na sila with the insulating material that mutes out the electric field. Okay? Pero pansin nila, bakit? So, ito mga repulsion na to, and then attraction, kapag same direction sila, nag-attract sila, this is not of nature of charges. Okay? So, hindi ito dahil sa mga charges. No? So there is something else at work here, and that would be your magnetic fields. Okay. So napansin nila that this has to do something with magnetic fields. So paano nila nalaman na magnetic field yun? No? So nagtry silang ngayon, maglagay ng compass around a wire, a current. And napansin nila na kapag tinabi mo yung compass dito, you would see that pag minove around mo yung minove around mo yung compass, it would trace out a circle around that wire. Okay. And amazingly, this follows your right hand rule. Okay? So yung thumb mo will actually be pointing similarly with your current, and then the curl of your arms would be the direction of the magnetic field. So whenever you have currents, there is a magnetic field. Okay? Okay? So yun. So how do we define current? Okay, so kapag may current ka, may magnetic field, di ba? Okay. So yung magnetic force, na-calculate siya by using QV. Look at this, capital Q to. So collection of charge to. QV will be your current, and then that will be crossed with your magnetic field, okay? Okay. So ayun yung na-calculate nilang force. So yung si Ampere, tinignan niya ngayon yung force between those wires, and napansin niya yung force ay kinalculate mo, lang siya, cross product lang siya ng current tsaka ng magnetic field. Okay, tingnan natin. V cross B, V cross B, pointing inwards or papunta dun sa kabila na wire yung force mo. Kaya nag-attract yung dalawang parallel na currents mo. Okay? Okay. Kasi yung field na nasa left hand na wire, yung magnetic field nito will follow the right hand rule. And kung titingnan nyo dito, pag ginawa nyo yung right hand rule dito, yung magnetic field will actually point into the page. Okay, ito yan. Into the page yung B na yan. So when you get the cross product between the velocity or the current itself with the magnetic field, makikita mo na yung force ay inward, papunta doon sa kabilang part. Kaya nag-a-attract sila parehas. Easy. Okay? So whenever you have in general, kapag meron kang electric field at magnetic field at the same time, makukuha mo yung Lorentz force, which is yung basically, inad mo lang yung dalawang force. May QV cross V ka for your magnetic, and then QE for your electric field. Okay? So may ganyan ka whenever magnetic and electric fields are present. Okay ba yan? Okay. So an important thing about the formulation of the magnetic forces, itong V cross V, is that yung magnetic force mo walang work. Okay? So, di ba ang work mo ay equal sa integral ng F dot dl. Okay, ano yung V? Okay, V is the velocity. Hindi ko pala nasabi, no? V is yung velocity ng charges mo. Okay, so basically, the strength of your current. Okay? So, para malinaw sa lahat. So, V ay direction ng current or yung speed ng current. So, define natin mamaya yung current para mas malinawan tayo sa buhay natin. So, naalala natin na yung work ay integral ng F dot dl. So, the derivative of work is actually F dot dl. Okay. And then, yung F ng magnetic field mo will be QV cross V. And then, dotted with D L. Okay? Okay? DL yan. Or DI. Teka lang, check ko para sure tayo. Okay, so ang F mo ay dW. Ang F mo will be your magnetic force, which is Q. B cross B. Okay? And then dotted with your DL mo with B will be the line in the direction of your V hat. Tama? Kung saan yung velocity ng charges mo. And then DL. Okay? Okay. So I can express this in other terms. Pwede ko express to as velocity itself. Then that would lead me to this expression. Pero I would not go there. I mean, okay na to. Ang point lang dito is bakit zero agad ito? Kasi V cross B is a vector that is perpendicular to both V and B. Okay? So kapag perpendicular na agad yung kung ano mang result ng V cross B, kasi the dot point with V velocity. That would zero out. Tama ba? Okay. So kuwari meron kang B, meron kang this is B, then V. Kuwari right angles to. This is a right angle. Okay. So yun, that product between these two will produce a vector that is both perpendicular to them. So we have this by the right hand rule. This is your V cross B. And what is the dot product between this guy and this guy? Diba? So that is automatically zero. Kasi perpendicular sila. Okay. Okay, so ayun. That would be zero. Okay? Okay, so reading assignment, tingnan nyo lang sa libro nyo yung example ng cyclotron motion tsaka yung cycloid motion. Okay, basically, itong dalawang to, meron kang magnetic and electric field. Tapos, titingnan mo lang ngayon kung paano gagalaw yung charge mo upon exposure sa mga magnetic at electric field. Okay? Okay. So, gamitin nyo yung force na ito. And so on and so forth. Hindi ko na di-discuss kasi medyo straightforward yung discussion ni Griffiths doon and madali naman siya. Okay, now we discuss currents. Siyempre, hindi ako na interesado sa force kasi ang most nagagawin nyo sa chapter 5 will be solving for magnetic fields. So to solve for magnetic fields, of course, you need first your currents. What are currents? So your current can be defined in 3 different ways. So parang charges natin dati, meron tayong charge density, di ba? So meron tayong line, meron tayong surface, and meron tayong volume. So similar lang din dito. Okay? For straight line na current, straight line currents, yung I mo will be defined by lambda times yung line charge density mo times yung velocity nito. Okay? Okay. So the force for this kind of setup, syempre babalik ka pa rin dito, QV cross B. Sige, balik tayo dun para hindi tayo mahirapan. F is equal to QV cross B. And if we're not given Q, the total Q, we're given a line charge, then this would be, of course, the line charge, V plus D, B cross D, TL. Okay? Medyo straightforward, di ba? Kasi ang Q mo can be expressed as the integral of the line charge times the line. Okay? So line charge density times line. That's charge. That's total charge. Okay? And then I know your lambda V is just your I. So this is just I, the vector I plus D, dl. And of course, dl runs the same direction as your I. So you can just simply write this down as yung magnitude na lang nung current mo times di, dl vector pala. L yan, guys, yung mga nakakalito, di ba? Okay. Plus B. Okay? So I can write that down as this guy. Okay? So si lambda V here, naging I siya bigla, I na vector. Then, siyempre may I na vector ka. Habang may I na vector ka, may magnitude na I. And then the direction of your current. And then now you know that the direction of your current is the same with the direction of dl. Okay, so in essence, you can just write down dl vector. Okay. So kuha ba yan? Okay. So let's try an example. No? Okay, so try natin mag-example. So a rectangular loop of wire supporting a mass M, so this guy, hangs vertically with one end in a uniform magnetic field which points into the page. So yung into the page ay pwede natin isulat as ganito. Into, then pag out, dot, circle na may dot sa gitna. Out of page. Okay? So in this case, into the page yan. So ito yung unang case na gagamitin natin. For other notations lang naman. So may magnetic field daw sa shaded region here. So for what current I in the loop would the magnetic force upward exactly balance the gravitational force downward? So we want to lift this, okay, by producing a current that would counteract the gravitational force. Okay, so what we need here is meron kang straight line na may current I. So we can use this guy. So F, the force is just the integral of I cross I dl cross t. Okay? Okay. So si dl mo, again, would run in the same direction of the current. So we have, i-breakdown natin, no? Meron tayong tatlong segment. So yung maliit sa left, yung mahaba sa taas, then yung maikli sa right. Okay? So the current in the left part will be upward. Sige. Kaya pa. Upward. So that's your dl. Okay? And then yung magnetic field mo would always be into the page. Okay? So up, tapos cross with the into the page. So gawin nyo yung right hand rule. So up, tapos into the page. So yung force mo would be pointing to the left. Okay? Okay. And then, Sa right-hand side mo, sa right-hand dito sa side, pababa naman yung current mo. So we have downward na current. So yung DL. Tapos meron kang into the page ng magnetic field. Kapag ginawa mo to, yung right-hand rule mo, DL cross V, yung force na makukuha mo would be to the right. Okay? Now, DL is length. So, this has the same length as this guy. Tama? Okay? So, same length. So, same force lang ang mangyayari. However, they are opposite. Opposite yung directions nila. So, magka-cancel lang yung contribution ng left and right sides. So, tingnan natin ngayon yung top part. Okay, so top part, to the right. To the right yung current mo. To the right, VL. Cross B. Tapos, yung B mo ay into the page pa rin, of course. So, yung force mo would be cross product nitong right and into the page. That will give me upward na force. Ooh! That's what we need, di ba? Kasi kailangan pababa yung force ng gravity. So, we need the force that is upward. Okay? So, lahat ba ng component ni current ay perpendicular kay B? So, yes, di ba? Okay. And then, B is uniform. It does not depend on the length. So, lalabas lang din yan sa integral mo. So, you have actually F is equal to I, tapos B, tapos integral ng D, L. Okay. So, we know that yung sides mo would not contribute to anything. So, yung DL mo would actually be just A. Tama? Integral ng DL would be from 0 to A. 0 to A. So, your force is iba. Iba. Okay? And then, this is your force due to your magnetic field. Okay? And this is upward direction. So, how do we counteract the gravitational force? Siyempre, equal mo lang yan sa mg. Diba? Kasi, ayun yung force due to gravity and to that mass. Mg iba. So, your I, the current you need to stabilize or to levitate the mass is just mg over BA. Okay? Amazing. So you can lift and levitate this guy by producing a current circling here with this amount. Okay? Okay, now, what happens if we increase the current? Okay, kung yung current mo ay this guy na, what happens if we increase? So, Kazumi, ano mangyayari pag in-increase mo yung current? What happens to the mass?
Sa mass po, po siya? Parang malilift po ba?
Okay, tama. Very good. Siyempre, pag tinasan natin, pag sinakto lang natin yung current mo dito, ang mangyayari, suspend lang siya mid-air. Ganyan lang. However, if you increase the current, of course, it would lift this mass. Now, the question is, kung increasing the current will lift the loop, or this guy, or the mass, does that do work? Ross, does that do work?
So, ano po ulit yun?
Okay, in-increase natin yung current. Tapos sabi ni Kazumi, tataas yung mass. Mal-lift, di ba? So, does that do work?
Sir, hindi po.
Bakit?
Sir, hula lang. Kasi po, di ba, work ay zero po yung work na ginagawa ng magnetic field.
Okay. So, yung magnetic field natin, tama. Tama na yun. Yung magnetic field mo, wala siyang ginagawang work. Okay? So, who does the work? kung nalilift yung ano, di ba kailangan may gumagawa ng work para malift yung bagay, di ba? So, who does the work? So, sinong gumagawa ng work? Yung nag-increase ng current. So, yung baterya or kung ano man, yung power supply niya, ayun yung gumagawa ng work. Hindi yung magnetic field. Okay. So, kung naiisip nyo sa mga movies, di ba, mayroong magnetic lift, yung parang crane na may magnet. Tapos tatapat niya sa kotse, mabubuhat yung kotse. Ganun. So, yung gumagawa ng work doon is yung baterya o yung power supply ng magnet. Okay? Yung magnet hindi siya gumagawa ng work. So, medyo medyo on the hindsight, di ba? Parang, ba't nag-work yung magnetic field? Pero in math, hindi siya nagagawa ng work. Okay? So, yung nagpapalakas sa current, siya yung gumagawa ng work. Alright. Now, ito ay yung pag-I mo. That's your line current. And kapag kuwari, may sheet ka ng metal, tapos may current na nagpa-pass through dun, magiging K na siya. Okay? So, sigma, gagamitin mo lang si sigma. And that sigma moves to a direction V. Moves with the velocity V. Okay, may tanong pala. Sir, dun sa previous example, hindi ko po gets bakit nag-scalar na lang yung DL para ma-integrate. Okay. Medyo parang mabilis ako dito. Okay. So ito, a cross product ng dalawang vector would produce a vector. Tama ba? Tingnan natin na yung the side parts, yung pataas at pababang current would actually contribute nothing to the force kasi magka-cancel sila. So, ito yung part na mahalaga sa atin. Okay. Okay, so nag-straightforward na lang ako dito na since perpendicular itong dalawa, this would actually be I, dl, b. Okay, so lagyan natin si b, dl times z hat. Okay, so ayun yung vector. Nilagay ko lang siya as upward symbol here. Kasi hindi ako nag-denote ng coordinate system dito. Okay? Kuha ba? Kung bakit naging constant bigla yung bakit naging scalar bigla. Okay, kasi yung tanong ay, ba't nag-scalar bigla yung DL? So, yung direction ng DL will be right. Tapos yung direction ng B will be inside the page. Into the page. So, yung cross product nun will give me an upward direction. So, yun yung vector na direction vector mo. Okay. Okay, sir, ba't walang to the left DL cross D? Ba't walang... Eto, meron to the left. Tapos meron din to the right. Tapos yung DL nun, same amount. So actually, 3 terms to. Di ba? 3 terms yun. So, sulat natin ang buo. DL cross E. It would give me 3 terms. So let's denote your horizontal. This is X hat. This is Z hat. Okay. And into the page yung Y hat. Okay. So this is actually 3 terms. Yung una will be B, IB, tapos DL, ito ay negative X hat, plus IB, DL, X hat, tapos the other one is IB, DL, DL, Z hat. Okay? And then the integral bounds will be 0 to A, And then, kung ano man length nito, so sabihin natin 0 to x. Para pangit. Z na lang. 0 to z. 0 to z. Okay, evaluate mo yan. Magka-cancel yung dalawang term. Cancel lang din to. Okay, so visually makikita naman natin, di ba? Okay? Ka-cancel to. Kaya walang to the left at walang to the right. Pataas lang yung force mo. Okay, tapos bale scalar na lang din po yung B. Yes, kapag kasi tandaan natin na yung cross product mo, di ba? Ang cross product mo B, pare meron kang vector A cross B. In general, this would be A, B sine theta. Okay, theta is the angle between the vector A and B. And then na-assure natin na yung theta between your currents is actually 90 degrees. Di ba? Kasi ito ay pag ganun. Tapos into the page yung vector mo, yung B mo. Okay? So 90 degrees lagi yung pagitan nila. So if AB sine 90, and that would give me, of course, AB na lang. Tapos, yung direction mo would be kung saan man yung perpendicular to both. Sir, bakit po walang y component yung integral ng magnetic force example po? Bakit walang y integral? Okay, sa force, yung force mo ay laging perpendicular to your magnetic field. Tama ba? Okay. Yung direction ng magnetic field mo ay into the page, so that is y hat. So wala kang force into the y hat. Tama ba? Nakuha mo ba? Kasi yung magnetic field mo ay y hat. Tapos yung prescription for your force is dl cross t. So automatically you don't have a force in the direction of B and in the direction of dl. Okay? Okay. So pansinin nyo, dito sa left-hand side, ang dl mo ay upward. So yung dl mo ay upward, tapos yung b mo ay into the page. So kuwari ito ay z hat, and this is y hat kasi into the page siya. Automatically, hindi magiging y hat at z hat yung force mo. So that is negative x hat siya. Same here. Okay? So this is negative z hat. Automatically, this is y hat. Kasi the field doesn't change. Ganun pa rin. Automatically, wala kang force sa negative z at wala kang force sa y. Kasi cross paradox sila. So, natira ay x hat. Cancellin mo, this is negative x hat. Makancel yan dalawa. And then here, to the right, so this is x hat. And this is y hat. Okay? So, x cross y, that's z. Okay? So, that's it. Okay. Any questions pa? Kung naguguluhan, tanong. Okay? So, tuloy tayo. Kanina, line charge lang, line current lang tayo. So, meron tayong sinatawag ng surface current, which is K, and then the volume current, which is J. Okay? So, yung force, due to that, is very straightforward. I-deconstruct mo lang si Q. So, naging sigma dA na siya dito. Pagtabihin mo sigma V, naging K na siya. Very straightforward. Okay? Magiging dA na integral dito. Then the force para sa rho will be d tau. Okay? We know that things. So meron kang I and then KJ. Okay? Okay. So you have that. Okay. Now, let's see. Okay, now let's look at this. Amazing lang kasi na from the definition of the current, napansin mo na makakabuo ka ng continuity equation. So kung we have a current, I. So, okay, so yung J mo, alam mo itong J. So we have, isipin natin some current passing through a surface A, like dA. Okay. Passing into the surface, okay. Yan, negative sign. We have this. Okay. Okay. In general, when some current J passes through a surface or goes in or out a closed surface, we can actually generalize this as closed surface as J dA. And then by the divergence theorem, is actually negative. Kinopya ko lang negative. Then del dotted with J. Okay? Bitaw. Volume integral na siya. So divergence theorem lang to. Okay? And then amazingly, yung I mo, which is just your dq over dt. So yung current mo, kung imagine niyo, pwede niyo convince sarili niyo na I would just be parang speed ng current, di ba? dq over dt. Kung ilan yung current na nagpa-pass through something onto some surface at a certain time. Okay, so that's dq over dt. And we know q is just an integral of rho beta. Tama ba? So we have the left-hand side d over dt, some integral of rho d tau. And then you can now write the right-hand side as the del dot j I. Del dotted with j data. Okay? And then, since yung bounds ng integral mo ay constant, I mean, hindi ito lumalaki with time, okay? Magiging partial na lang siya. And dito. So in essence, yung nasa loob ng mga integral should be equal. So del dot j negative. Okay. So ano ibig sabihin nitong continuity equation? So whenever you have a current J spilling out somewhere, okay, kung nag-spill out siya somewhere, nag-diverge siya somewhere, then yung total charge mo inside would decrease over time. Makes sense, di ba? Siyempre, pag nagbuhos ka ng something, makabawasan yung kung nasan yung timba mo. Kuwari, nagbuhos ka ng timba, di ba? So, yung pag-flow ng tubig, that would be your current. Tapos yung amount of water inside your timba, that's your charge. So, pag binuhos mo, mababawasan yung nasa loob ng timba. Okay? So, wala lang, fun lang. So, babalikan din natin to next kapag nag-magnetic fields in matter na tayo. I-derive ulit natin to. Kasi parang di convincing yung derivation dito, di ba? Parang focus lang. So we'll have a more rigorous derivation of this sa chapter 6. Okay? Now, okay, sir, parang Okay, para saan po ginagamit ang continuity equation, sir? Ginagamit to pan-derive ng mga bagay-bagay. So, hindi pa to pan-check. Mamaya pa yung mga pan-check natin. Actually, hindi ngayon. Hindi ko ma-discuss ngayon. Okay, so, you might be lost right now kung ano pinagdi-discuss din. Kala ko ba uulit lang tayo sa parang sa electrostatics. So, basically, diniscuss ko lang muna yung forces and then yung current. Di ba? Kasi yung current magpo-produce siya ng field. Okay, so yung force, kasi may field ka, so may force. So now we go to the Biot-Savart law. Okay, so French to Biot-Savart. So hindi pinapronounce yung T. Okay. So sa electrostatics natin, may stationary charges tayo. Kaya meron tayong constant electric field. So that is electrostatics. Sa magnetostatics, ang constant mo ngayon ay yung magnetic fields. So dapat steady currents lang yung meron tayo. Okay. Ano ibig sabihin ng steady current? Ang steady current ay yung hindi nagbabago over time. Hindi tumataas, hindi bumababa. Sir, ngayon po ba ang total charge pa rin po dinidenote ng Q? Yes. Total charge is capital Q. Well, you can define your own total charge. Okay. So, sinabi ko naman dito na total charge siya. So, yeah, that is your total charge. Okay. So, pag steady currents daw, meron kang constant magnetic field. Okay. So, what does that imply? So, dapat yung change mo ng current mo will be zero. Okay? Hindi dapat siya nagbabago through time. Okay. So, yung continuity equation mo would reduce to del dot J is equal to 0. Okay. So, this is very important. Gagamitin natin siya soon. Basta sa magnetostatics, remember that del dot J is equal to 0. Okay. Now, syempre, ito na. Nung pagkuha natin ng electric field, meron tayong mahirap na way para kumuha ng electric field. Now, in magnetic field, this is it. The Biot-Savart law, ito yung mahirap na way para kumuha ng magnetic field. Okay, so this is given by this guy. Okay? So yung B is your magnetic field, mu naught over F4 pi. The integral of I cross R hat, yung curly R hat, all over R squared. Okay. So siya, ginawa niya, pwede mo rin itong ilipat as, again, similar in direction, equivalent in direction ng I. So DL prime. So you can actually write this as DL prime vector instead. Okay? Let's cross R, curly R hat. Okay? Okay, so these are the two forms of your magnetic field. Okay, so si mu naught, parang si epsilon naught, tinatawag siya na permeability of free space. So si epsilon naught ay permittivity of free space. Okay, so si mu naught, pag magnetic field ka na, permeability of free space. Ang value niya ay this guy. Basically, 4 pi lang siya, no? Na raised to something. Okay, ang units ng magnetic field ay Tesla. Amazingly, yung mas ginagamit na unit for magnetic fields ay yung CGS unit niya. Okay? So, ano yung CGS? Centimeter, gram, second. Okay, so yung mga level ng centimeter, gram, ginagamit niya yung units ay Gauss. Okay, bakit? Kasi sobrang laki ng Tesla. So yung magnetic field ng Earth ay kalahating Gauss lang. Okay. So yung sa mga labs natin, yung mga artificial magnetic fields, 1 Tesla lang sila. Sobrang lakas na nun. Okay. So amazingly, mas ginagamit yung CGS units. Of course, we'll have an example. Diba? So example, find the magnetic field at distance S from a long straight wire carrying a steady current I. Okay. So we're safe. Steady current I. Okay. Magnetostatics. Gamitin natin si Biot-Savart law. Okay? So i-breakdown lang natin. Alam natin na si curly R would be your distance from your charges to the point of interest. Okay, that's very straightforward. And then, what else do we not know about this? So, si DL prime would be kung saan yung path ng current mo. Okay, so, ang path ng current ay this guy. So, we denote L prime as this length, and DL prime as your infinitesimal length. Okay, so, solve natin tong bagay na itong dalawa. And then, we can move on with our integral. Very easy. Hopefully. Okay. Okay. Mag-denote tayo ng theta, no? Para madali. Theta is between the angle between R, curly R, and S. Okay. So, what is the relation of S and curly R? Eliza, are you there?
Yes po, sir.
Okay. Anong relation ng bigyan ng relation ng R, curly R, at S?
Gamit po ba dyan, sir, ng mga data?
Gamitin mo yung theta para madali ang buhay natin.
Paano natin? Wait lang, sir. Cosine.
Yes. Galing. Tuloy mo. Sige. Cosine. Ano? Kailangan mo ng tulong?
Naririnig po ba?
Ay, hindi. Sorry.
Sorry, sir, nag-lag. S over curly R cosine theta. Or baliktad po ata.
Ano? S over
Over curly R
is equal to?
cosine theta.
Very good. Galing. Okay? Hindi ako sanay mag-isip ng ganito. Hindi ako sanay dito. Di ba ito ay dahil sa SOHCAHTOA? Kasi ang cosine theta ay adjacent over hypotenuse. So, adjacent is S over hypotenuse. Okay. Ang iniisip ko kasi pag ako nag-solve ay S is the projection of R with respect to theta. So, ako is solve ko siya as this. Okay. So, wala lang. Kanya-kanyang isip tayo. Okay. So, we now have an expression of so, yung 1 over R squared mo. Yes. Pangit dito na sulat. So, yung 1 over curly R squared, ay kailangan natin to, di ba? Kasi sa BS of R, may over R squared, curly R squared. So, we need this. So, from here, this is just cosine squared theta and over S squared. Tama? S squared. Okay. Goal number 1 complete. So, ang problem na lang natin is DL prime cross R curly R hat. Okay, what is this? I know that this is just DL prime times yung magnitude ng R hat, which is just 1, and then the angle between them, sine. Okay, let's denote that as alpha. Okay, so ito yun. So yung DL ko will be running here, tapos yung curly R ko running there. So yung cross product nila would be the magnitude of this times the magnitude of this times sine alpha, which is the angle between them. Okay, ito yun. Okay. Now, hindi mahalaga sa atin si alpha eh. Ang mahalaga sa atin si theta. So we want to write sine alpha as some function of theta. Okay, paano ba natin gagawin yun? Okay, hindi ko alam kung ganito kayo mag-isip, pero ganito ko siya gagawin. So whenever, kunwari, meron kang, okay, irrelevant tong coordinate system na to sa problem natin. Gusto ko lang i-demo. So whenever you have some vector, ang vector na to ay A. Okay? Then may theta ka. Theta. Okay? So, ang mangyayari kapag yung A cosine theta, that is just a x. Okay? So, yung projection niya dito. So, katabi ng theta. This is your ax. So, yung haba na to ay ax. And then, pag sinine mo naman, sin theta, magiging ay siya. Basically, titignan mo kung anong height niya. Okay? So, ganito ko iniisip yung purpose ng sin theta at cosine theta. Okay. Okay, so dito, titignan ko ngayon na yung sir, yung mga cross products po sa equations natin, magnitude po nila talaga yung kailangan natin. Yes. Again, A vector cross B vector is just magnitude of A times magnitude of B. Okay, hindi that product yun. Magnitude of B times sine the angle between them. Okay? Sine whatever angle. Ayan. Okay? Tapos yung direction, mamaya mo na problemahin. Just patch it up later on. Okay? Basically, dapat ito ay may extra factor na A hat cross B hat. Para maging ano siya, satisfying itsura niya. Okay? So, ganito yung general form. Yung B hat mo kung saan yung direction ng ano. Okay? Okay. Okay, now we go back to kung paano ko i-imagine yung mga bagay-bagay. Okay. So, imagine this guy, DL. Kuwari may length siya na ganyan. Now, I have to rotate it by alpha. So, kuwari, itong length niya, magiging ganito na siya. Okay? So, kapag kinuha ko yung DL prime sine alpha, this would give me the height of DL. So, this guy. Okay? So, this amount. Okay? And amazingly, if we write down a parallel line here, sorry, ganito ko siya naiisip. You can have your own way. Okay. And of course, this is by your geometry, this is the same theta. Okay, theta. Okay, ano tawag sa rule sa geometry niya? Basta same lang yan. Basta parallel tong dalawang line na to. Immediately, yung theta mo will be same theta here. Okay. Yung theta to, then yung projection, yung length, yung magandang color. So, kanina, di ba, yung katabi ng theta, pag kinocine mo, ay yung AX. So, yung katabi ng theta, this guy. So, this guy. So, yung projection at DL, with respect to theta, with respect to this green line, is just this, which is just the same as this guy. Okay. So, in essence, DL prime sine alpha must be equal to DL prime cosine theta. Okay? Okay. So, baka di nyo na-gets yung way ko. So, find out kung paano nyo siya mai-imagine. Okay? Okay. So, again, this is just DL prime cosine theta. Okay. Hello, Danny. Are you there? Hello? Mukhang hindi ka namin naririnig. Chat ka na lang. Can you chat? Can you chat? Can you chat? Say. Ayan, nag-chat na siya. Okay. Okay. Can you have an expression na magre-relate sa theta, L prime, and S? Okay. Anong relation pwede mong magawa with theta, L prime, and S? Danny? Type mo na lang siya para hindi ka mahirapan. Kaya pa ba? Need ng help? Need ng help, Danny? Okay, wala siya na. Okay, need ng help. Tulungan mo siya, Lance.
I-relate ko yung
Theta,
L
L prime,
prime
tsaka S.
Tangent. Pwede kong gumamit ng
Tangent, ano nang?
tangent theta equals L prime over S.
Very good. Okay, very good, very good, very good. Parang ginawa lang ni Eliza kanina, no? Na yung nirelate niya yung tangent tsaka S just. Tapos R. Okay, okay. Very good, Lance. Okay, now we have an expression that would relate again L prime and theta. Bakit ba natin ito ginagawa? Kasi nakuha natin na 1 over R kanina, 1 over R squared is dependent on theta. Okay. So gusto ko mag-integrate sa theta. Ayun ang point ko. Okay? Gusto ko mag-integrate with respect to theta. So I have to write down dl as a theta. Okay, ano yung nakuha ni Lance na expression? Tangent theta is just L prime over S. Okay, let's get the derivative of this. How ba? Yes. Derivative of this would be S secant squared theta d theta must be equal to dl prime. Now we're ready. Okay. So yung dl cross r ko would be just S secant squared theta d cosine theta d theta. Okay, so basically pinlog in ko lang tong dl dito sa dl prime cosine theta. Now we're ready to build the equation. So b is just mu naught I over 4 pi integral ng yung dl cross r ko. Yung dl cross r would be s secant squared cosine theta d theta. So let's write that down. S secant squared theta cosine theta d theta. Okay? And then yung 1 over curly r squared ko, ano yung sinabi na sagot ni Eliza? It's here. Okay? So basically, I will multiply cosine squared theta and divide by s squared. May cosine squared pa ako dito. Theta d theta. Okay? Okay. Okay, so now we continue to solve this. Mu naught I, 4 pi, and then cancel yung isang s, so may s na lang ako dito. Hindi naman siya ma-integrate, di ba? Hindi naman gumagalaw yung s natin. Tapos secant squared cancels with cosine squared. Tama? Kasi ang secant squared ay 1 over cosine squared. So magka-cancel siya with cosine squared. And we're just integrating cosine squared, like cosine theta d theta. Okay? So I just put a random arbitrary bounds. Okay? Depende kung gaano kaaba yung length ng wire natin. Okay? So the integral of cosine theta is simply sine theta. So we have mu naught I over 4 pi s. 4 pi s. Tapos sine theta 2 minus sine theta 1. Okay? Okay. Okay. So what is theta 1? Ito, theta 1, theta 2. Tapos ito project, makikita mo ngayon na ayun yung mako-cover mong distance. Okay? Nakadepende sa theta 1 at theta 2. Now suppose, di ba ang problem natin is long straight wire. So with this, makikita natin na yung theta 2 natin, if yung wire natin would be extending to infinity, yung theta 2 mo would approach this whole thing. Okay? Aabot siya ng ganito. Na right angle na siya. So 90 degrees for theta 2. And then, yung theta 1 mo, mag-start siya from negative infinity. So it would run like this. And again, this is a right angle. 90 degrees din yan, pero negative 90. Okay? So that is your theta 1. Okay? So plug in that. Plug in natin na makukuha natin kapag very, 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 very long straight line or approaching infinity na yung straight line, we would have 4 pi s sine 90 degrees or pi over 2 minus sine negative 90 degrees. This gives me 1 minus negative 1. And copy this. So your B, the function of S would be mu naught I. Mu naught I times 2. Cancel ko na siya sa 4 sa baba. 2 pi S. Okay, the direction would now, paano yung direction natin, sir? Vector kinukuha natin, di ba? Again, sinabi natin na yung magnetic field would circle around your current. So if yung current mo ay papuntang ganun, tapos dinenote na natin to yung radial distance as S, then it would be comfortable to use the cylindrical coordinate system, and our direction would be C hat. Okay? So paano ba yung tsura niyan? Sorry. Vector niyan. Okay, so imaginein natin na yung field would be circling out, would be circling around your current. Okay? And this direction is phi hat. Sir, yung equation po ba Sir, yung theta po ba sa figure 5.18 ay equal sa theta 1 ng Okay. So may tanong tayo, sir, ito yung theta po ba sa figure 5.18, so this one, ay equal sa theta 1 ng no, hindi siya equal. Okay? Basically, theta 1 would denote your initial line. Okay, this guy. Okay. Kasi ang gusto natin, di ba, sa integral natin, ma-integrate yung buong length ng current mo. Okay? So, yung buong length ng current mo would be, of course, the buong length. Pero if we're just gonna get a wire segment, yung wari, itong segment lang na ito, then this guy, yung left-hand side mo would be denoted by theta 1, and then the other side mo would be denoted by theta 2. Okay? Does that make sense? So, imbis na mag-ano tayo, kasi nag-shift tayo, di ba, kung wari, let me explain that a bit further. Nag-shift tayo ng integral ng dl to integral ng d theta. Suppose that this is a to b. Okay. So, kuwari a to b ang segment na yan. Then, yung theta mo, corresponding theta, will be theta a, of course, and then theta b. Theta. Yung theta a would denote this guy. Kuha ba? Nagets ba? Chat lang ako nagets. Sorry. Baka hindi ko magets yung problem. Okay. So, may chinat sa atin, no? May chinat pala kanina. Kasi medyo, feel ko hindi kayo na-convince dun sa sin alpha ko. Sin alpha. Okay. So, an easier way to do this is, since you know sin. Okay. From here, alam mo na theta to agad, tas ito ay 90 degrees. Okay. So, yung alpha mo ay pi over 2, 90 degrees plus theta. Okay. Okay, so pag sinain mo to, sin alpha, ito ay sin theta plus pi over 2, and that is just cosine theta. Okay, mathematically, ayan siya. Mas madali, di ba? Okay. So, ayan yun, no? Mukhang mali na bigay mo sa chat, pero maganda yung sense. Okay? Okay, another question. Bale, sir, dahil po sa direction na magnetic field, kaya po tayo gumamit ng cylindrical instead of Cartesian. Kaya tayo gumamit ng cylindrical kasi mahihirapan tayo mag-express ng direction. Okay? Mahihirapan tayo mag-express ng direction. Kasi kunwari, so drawing ko na lang ulit yung kunwari, we have a current here. This is your I. Okay? And then we want to get the field at this point. Okay? And then the magnetic field, of course, would circle. Okay. Would circle here. So at this point, yung magnetic field mo ay outward the page. Okay? At this point, kuwari kinuha mo naman yung kabilang side. Kinuha mo yung other side here. Hindi natin R yung point na yan. The magnetic field there would be into the page. Okay? Into the page. And kapag lagyan natin ang gana, parang tayo mahirapan. Kapag kinuha mo yun sa dulo, kabilang side, pataas naman yung direction mo. So, dito naman pababa. So, mahirap mag-generalize ng direction kapag mahirap mag-express ng direction kapag ganito, no? Nakas na ba yung dilemma natin? Bakit di tayo gumamit ng Cartesian? Okay? Kasi kapag nagbago ka ng point, kuwari, lumipat ka at here. So, same problem din naman, pero magugulat ka, pabaliktad na yung field mo. So, in essence, mas madaling tawagin na phi na lang. Okay? Sir, mostly po ba ng pag-express ay cylindrical? when that depends on the problem eh. Depend. Okay. Ang mahirap dito sa magnetostatics is yung pag-imagine mo ng magnetic field. Okay? Kasi this time, di ba, kapag may line charge ka, let's say we have a line charge, we have a line charge, yung magnetic field mo will just radiate out of this guy. Okay? So, yun yung electric field mo kapag may line charge ka. Nagra-radiate lang siya at points. Okay? So, medyo madali siyang isipin. And medyo madaling umisip ng coordinate system na madali for that. However, dito kasi sa mga kapag sa magnetic fields naman, nagsisircle siya lagi sa current mo. So, mahirap siyang isipan ng proper coordinate system. Okay? For line currents, madaling mag-cylindrical coordinates. Okay? Ayun lang, feel ko ayun pa lang yung ma-generalize ko ngayon. Okay. So how do we get this mathematically? Pwede mo siya makuha mathematically dahil ayun yung madaling ano natin. So DL cross R, dito ka magbabase. Okay? So pili ka ng coordinate system mo that would accommodate your problem. Okay? Okay. Isipin na pwede natin isipin na pwede tayong gumamit ng cylindrical coordinates kasi pwede natin isipin yung DL natin as DZ kasi may S na tayo. Diba? Okay. And then we have your S is equal to R cosine theta. Okay? Tapos, pwede mo isulat na DZ ay this guy as your DL. Right? So, DL prime, DZ vector cross your R hat. So, you need to find R hat in terms of cylindrical coordinates, then mapaproduce mo yung field. Okay? So, pwede niyo siyang gawin mathematically with the help of your, of course, yung nasa likod ng Griffiths niya. Okay, kung nalilito kayo dun sa ma-imagine lang ng mga bagay-bagay. Okay, kuha ba? Get it, guys? Tinitingnan ko ngayon kung paano siya isulat as cylindrical coordinate. Well, mahirap. Isipin nyo na lang na cylindrical coordinate siya. Okay, so again, you can do this mathematically. You just need to write down R hat in terms of your S over cosine theta. Tapos, actually, kailangan mo rin isulat si theta as your, basta kailangan maayos yung coordinates niya. Okay? So, si R ay similar sa Similar yan sa spherical coordinates mo. Na ano, kung gusto kong gawin. Gusto ko siyang gawin. Ako curious ako. Kung paano siya gawin. Sige, mamaya. Balikan natin pag natapos natin yung class. So, dali. Okay? I'm curious. Pangit talaga. Okay, anyway, sa Bios of Arlo, you can, since yung ginawa lang natin ay line charge, pwede mo siyang i-elevate, of course, to your surface charge, surface current, K, and then the volume charge, J. Okay? Then, superposition, of course, applies to magnetic fields. Kanina pa natin siya ginagawa, superposition to. Okay. Kina-clarify ko lang explicitly that you can use superposition to find the magnetic field. Okay? Now, merong example sa libro. Circular line charge. So, circle. Okay, circular line charge. Ay, circular current pala. Sorry. Nakalita. Okay, so paikot na current. I ka. And then, hanapin mo raw yung electric field at the center. Okay. Okay? So, again, you try first to imagine what the magnetic field looks like. Okay? So, sabi natin, nagsisircle yung magnetic field around your current. So, right-hand rule, since papasok dito yung current mo, gawin mo yung circle. By the right-hand rule, this tells me that upward, ay baliktad, right-hand rule, so pag ganito, ay tama pala, pag ganito. Okay? And then on this side, imagine ko lang muna kung paano yung field ko. And then that would be using the right-hand rule. Ano mo? Circle ko ulit. Yes, circle yan, sir. Okay. Yes, kaya ko to. Up, sobra. Okay, yun. Then, this is this. This is that. Okay. So, they circle out, no? Okay. So, yun yung mga magnetic field mo in red. So, in this side, kung mapapansin nyo, kapag ginawa ko yung magnetic field dito, yun siya. Tapos upward, mas malapit sa atin, downward yung nasa likod. And on this side, pag ginawa natin sa malapit sa atin, yung malapit sa atin would be downward and yung malapit sa gitna would be upward. Kung mapansin nyo, if I extend this to malaki yan, syempre tuloy-tuloy lang ang magnetic field mo. Mas malaking circle, mas malaking circle, malaking circle, mas malaking circle. And napapansin nyo na yung electric field at this point would be, syempre upward to, puro upward. Napansin nyo, upward yung magnetic field sa gitna ng point. Okay. But this guy, so mas madali siyang gumamit ng Cartesian coordinate kasi upward lang yung direction mo in that point at the center of the circular current. Okay, so example to sa libro, you can try this one out. Okay? Okay, so Z hat yung magnetic field dito. B Z hat at center. Okay? Okay. Sometimes, pag-solve natin ng magnetic field, mas maganda gumamit ng coordinate-free systems. So, mag-example tayo ng next time para hindi kayo nalilito sa coordinates. So pwede natin siya express actually as coordinate free. Amazingly. Okay? So that's your view sa bar law. Tapos, di ba sa electrostatics, di ba ito yung mahirap na way? Tapos nung nag-divergence and curl tayo ng electric fields, nabuo natin yung Gauss's law, which is dumali yung buhay natin significantly. So gagawin din natin sa magnetic fields, no? Para makita natin kung may magagawa ba tayo way para mapadali itong bagay na ito. So kasi di ba nakakalito yung may direction. Okay? So let's find something easier. So now we take the divergence and curl of your magnetic fields. So magnetic fields in general would look like this. So for a current na volume current, you have J. So this is your general. And now let's look at tingnan muna natin kung saan sila dependent. Okay? So si B, dependent yan sa unprimed coordinates. Okay? Ano ibig sabihin ng prime? Unprimed? So yung unprimed coordinates would be the coordinates that you are interested in. Okay? Si J, yung J natin, the current itself, is a function of primed coordinates. Yung primed coordinates, recall lang natin na sila yung coordinates na merong charges or merong current. Okay? And then si curly R is a function of both. Kasi separation to ng primed tsaka unprimed. Okay, so x minus x prime. So this is your in Cartesian coordinates. This is your R, curly R. And then d tau prime, of course, is prime coordinate kasi naka-prime siya. Okay? Okay. Now, we get the divergence of B. So, del dot B. Del dot B. So, del dot J cross R hat over R squared. So, hiniwalay lang yung R squared. Okay? Gets naman, no? Na hiniwalay lang siya para malipat sa dalawang term. Okay? Okay. So, del dot this guy. Now, we invoke the product rule sa likod ng libro natin. And we see that the divergence of A cross B is just this guy. B dotted with del cross A, then minus A dotted with del cross B. Okay, so B ay yung may mga curly R, so this guy, ito yun. Okay? Del cross J, then the second term is J, yung A mo, dotted with del cross yung curly R's. Okay? Okay. The first term, tingnan natin, del cross J. Si del ay unprimed. Okay? Kasi kung primed siya, kung del prime dot B ginawa natin, automatically zero to. Kasi B is unprimed, then primed yung pang derivative mo. So, wari, ang B mo ay X, tapos X prime. Siyempre, zero agad yan. Kasi X prime ito, tapos ito X lang. Okay? So, intuitively, ang kailangan natin kunin ay del dot B. Okay. So, si del cross J, unprimed times prime. J is prime. So, del cross J, that would be 0. Di ba? Kasi kunin mo yung derivative nung J, di ba? So, 0 agad yan. Okay? And then, del cross R hat over R squared, pwede natin siya isipin as R lang. Kasi N lang naman yung derivative natin, di ba? Hindi naman natin, wala naman tayong paki dun sa mga, wala naman tayong paki sa mga prime coordinates. So in essence, when you take the derivative of this, you try to get the curl of this, you have this in general. Okay? So del cross, the curl of R raised to N times R hat would be this guy, so, ito ay kinuha dun sa likod ng libro nyo kung paano mag-curl. Okay? And you'll find that this is your result. Okay? And if N is equal to -2. Kasi, di ba, nasa baba siya. So, plug in may -2 dito, just zeros out. So, the divergence of your magnetic field is 0. Okay, nice. Okay, so may ma-formulate tayo mamaya dito. Kasi kung maalala nyo, si del cross E, yung curl down ng E ay 0. So may na-formulate tayo dito na potential na tinatawag natin. Na-formulate natin dito yung E dot dl. The integral of E dot dl is just your potential of B minus A. Okay? So yung V ay potential, amazingly, na na-formulate natin dahil sa del cross E being 0. So del dotted with B, soon, may ma-formulate din tayo. Okay? For now, hindi natin siya i-discuss. For now. Okay? Next, we go to the curl of your magnetic field. Okay, so basically, kopyahin mo lang din ulit to. Then you apply the curl. So del cross B, del cross this. Oops, mahaba na yung natin ngayon. Problem natin ngayon. Okay? Mahaba na yung problem natin. Si A ay primed. Okay, so sulat natin. Lagyan natin ng prime para tayo malito. Dahil si J ay prime coordinate. Okay. The derivative ng prime coordinate ay 0. Okay? Kasi unprimed yung pang-derivative mo. Dito rin, unprimed pa rin to. So, the derivative mo yung prime. So, 0 lang din. So, we're left with 2 terms. The 2 middle terms. Okay? So, si -1, ilagay natin sa pangalawa. So, si J ay yung A mo. J dotted with del. B mo yung curly R. Okay, so this guy is this guy. And then the first term is given by the third term. Okay, so si A prime mo is J again. Then del dotted with R hat over curly R squared. Now we have solved this guy. Sa first chapter natin, sa first lessons natin, we see that this is the definition of your Dirac delta, which is given by this. Okay. Now, papakita ko mamaya na mag-zero out lang to. So, we're left with this guy. So, pag-plug in natin yan dito. Okay. So, mu naught over 4 pi. Tapos, J. R prime, di ba? Prime coordinate si J. Tapos, plug in mo to dito. 4 pi Dirac delta. Dito. Okay. So, gagalaw natin si prime coordinates. Kasi dito yung natin. Dito prime yung natin. Integral natin. So, si R prime, mag-a-adjust siya towards R para mag-zero yung argument nito at para magkaroon to ng value. Basically, you just plug in R. Tapos 4 pi cancels out. So, del cross B, and this is a very important example. Del cross B is equal to mu naught J. Okay. So, from here, ito yung magpapadali sa buhay natin. Okay, tandaan natin yun. Papadali ito sa buhay natin. Last time, di ba, ang nagpadali sa buhay natin is del dotted with E. Ito ay parang rho over epsilon. Di ba? Parang ganyan yun, di ba? Nakuha natin na ito yung Gauss's law, nagpadali siya sa buhay natin. Okay. Now, syempre, di pa tayo tapos, no? Di pa tayo tapos dun sa... Kasi sinabi natin mag-zero out tong second term, di ba? Okay, so balik tayo dito para lang makampante yung utak natin. So that term is this term. Okay? Now, pag naglipat ka ng prime coordinates from unprimed to primed coordinates, you will need to add a negative sign. Okay? For this, kasi tingnan nyo to, ang easy proof nito would be, huwag yung pansin, yung mga dumi lang yun. Easy proof nito would be this guy. Okay, so this is your unprimed coordinates taking the derivative of your f of x minus x prime. So yung x minus x prime ay simply yung curly r mo, di ba? Okay. This would be actually the same with this guy. Okay? So ayun yung parang simple proof lang na para makampante kayo na hindi to hocus-pocus. Okay? So kunwari, let's write down this guy. Kunin lang muna natin yung x. Okay, kasi addition lang naman yan, di ba? Addition lang naman yan. Kunin lang muna natin yung x hat. Okay? So if we write that down, we'll actually have this. Okay? Okay ba? Okay. So bakit naging r cube? Ilipat nyo yung, saan mo yun? Okay, dito sa definition niya. Ano mo yung, transform mo yung x hat. Okay? Okay, anyway. So ayun, para makonvince kayo na yun. Kinuha lang natin muna yung x. Tingnan lang natin yung behavior niya. Behavior lang naman. Titignan natin dito. Okay? So, j dotted with del. Tapos, some factor here. Kapag ginamit natin yung product rule sa likod ng libro, we'll actually have two terms. This guy and this guy. Okay? The product rule yan sa likod ng libro, which will give me these two terms. Okay. Magnetostatics. This is 0. Sinabi natin ito sa una. Kita niya? Del that the divergence of J is 0 for magnetostatics. So we're actually left with this guy. Okay? So going back, this guy should be equal to this guy. Okay? Okay, so yung x component part nito would actually be equal to this. Okay? Okay. Now, we integrate it. Integrate lang natin ito, no? With the entirety of the volume. Kasi, ito ay, ipa-plug in ko to ngayon sa B ko, di ba? Ang B ko ay yung del cross B pala. Be some integral. Minat tayo for 5. Minat na lang para safe tayo. For 5. Then, some integral ng del cross something, di ba? Dito. Okay? So, this guy, meron tayong 4 na terms. 4 terms. Dalawa nag-zero out kanina. Zero out. Tapos yung isa, nakuha na natin, which is this guy. Tapos ito na lang natitira. So, kailangan din natin siya ipasok dito. Okay? So, the integral of this, pasok na natin dito. Del dot something. Del prime dot something. Okay? Something. And then, divergence theorem, actually get this. Actually, get this guy. A dot PA. Okay? Okay. Prime. Okay, ayan. Divergence theorem lang yan. So, we have this expression. Okay? Okay, now what are we looking at? Ano bang goal natin, sir? Ang goal natin is mapag-zero out to, di ba? Kasi sabi natin zero out lang siya. Okay? When we look at this, tingnan natin na yung j.dA will actually be 0. Kasi, ano ba yung integral natin? Integral natin for the views of R, here, is to enclose the current. Okay. Kailangan natin ma-enclose yung current over some volume. Okay. Pwede natin extend the O to infinity yung volume. Kasi at those boundaries sa infinity, wala namang charge, wala namang current dun, kaya okay lang. Kaya dito, hindi na naka-all space to. Kasi sinasabi niya lang na integrate mo lang sa kung nasaan yung mga current mo. Okay? Now, kapag ganun kalaki yung integration bounds mo, this has to be 0. Kasi lahat ng current mo ay inside. Nothing goes outside. Diba? Kuwari, meron kang circular na current. Yan. Kapag kinuha mo yung some area here. Okay, some closed area here. Of course, may makikita kang pumapasok, may makikita kang lumalabas. Diba? May makakompute kang lumalabas. So, if this is your A, J.EA, would actually be finite if this is your your volume or your surface, no? So if we are going to get the whole current, there's nothing that goes in or out. So this is actually 0. Okay? Okay. Okay. So yun, no? So in essence, this is your divergence and your curl of your magnetic field. So del dot B, 0. And then the curl of your B is mu naught J. Okay, and we will discuss this next meeting para makita natin yung power nito. Kung gaano siya kadali. Okay? Okay, any questions? Magulo, no? Magulo yung topic natin ngayon. Mahirap ng magnetic fields. Kasi hindi straightforward yung mga cross products mo. Okay? Mahirap yung mga cross products. Mahirap siya imagining. Okay, any questions, guys? Meron ako i-post na prob sets mamaya. Okay, hindi ko lang nalagay dito. So, look out for that. Okay, so sabihan niya na lang yun yung mga klase yung hindi naka-attend. Alright? So, that's it. Tapos na yung lesson natin today. Again, things are prob sets, yes. 4 na questions. Next week ang deadline. Tuesday. Okay. Again. Next week na. Okay, so magandang strategy, no? Pag kasi di ba by pair naman kayo. By pair yung iba sa inyo, by pair mag-solve ng prob set, yung iba gusto mag-solo. Pag by pair kayo, okay, di ba usual ginagawa nyo, pwede nyo hatiin yung problem. Kuwari 4 na problem. 2 sasagutan ni member number 1, tapos 2 sasagutan ni member number 2. Okay? Pag ginawa nyo yun, ang magandang gawin is, okay, si member number 1, titingnan niya yung gawa ni member number 2. Babasahin niya, does this make sense? Okay? So, ganyan nyo i-check. Okay? Kung nagigets ba nung kapartner yung ginawa niya. Okay, yun lang. So, again, guys, tulungan niyo akong bigyan kayo ng mataas na grade. Ha? Okay.